In the vast expanse of our solar system, far beyond the familiar glow of our own moon, lies a realm of celestial wonders. Among these wonders are the moons of Saturn, each a world unto itself, each holding secrets waiting to be unlocked. Saturn, the ringed giant, reigns over a retinue of over 80 known moons, their icy surfaces reflecting the distant sunlight. These moons, varying in size from small, irregular bodies to Titan, a moon larger than the planet Mercury, offer a glimpse into the diversity and complexity of our cosmic neighborhood. Among these icy sentinels is Fenrir, a small, enigmatic moon named after the monstrous wolf of Norse mythology. Discovered in the early 21st century, Fenrir is a relative newcomer to our understanding of the Saturnian system. Its small size and distant orbit make it a challenging target for observation, yet its very existence sparks our curiosity and beckons us to learn more. What secrets does this distant world hold? What can it tell us about the formation and evolution of our solar system? Fenrir, like many of Saturn's outer moons, is thought to be a captured object, drawn in by the gas giant's immense gravity. Its journey to become a satellite of Saturn likely began in the early days of the solar system, a time of chaos and collisions when planets and moons were still coalescing from the swirling disk of gas and dust. By studying Fenrir, we gain a glimpse into this early era, piecing together the history of our cosmic neighborhood. Fenrir's small size and icy composition place it among a class of objects known as irregular satellites. These moons, often characterized by their eccentric orbits and tilted orbital planes, are thought to be remnants of the early solar system's building blocks. By unraveling the mysteries of Fenrir, we gain insights not only into the Saturnian system, but also into the processes that shaped our solar system as a whole. In the chapters that follow, we will delve deeper into the story of Fenrir, exploring its discovery, its physical characteristics, and its place in the intricate dance of Saturn's moons. Our journey to Fenrir begins in the control rooms of NASA's Jet Propulsion Laboratory. Here, the story of Fenrir's discovery began. In 2004, Cassini arrived at Saturn, ready for its mission. Cassini studied Saturn, its rings, and moons in detail. Among the data, a new moon's signature was found. Cassini's images revealed faint glimmers of distant objects. Each image held the potential for discovery. It was in a series of images taken by Cassini's Imaging Science subsystem, a sophisticated camera system designed to capture high-resolution images of Saturn and its surroundings, that the first hints of Fenrir's existence emerged. These images, taken over a period of several days, revealed a faint, previously undetected object moving against the backdrop of stars. At first glance, it appeared as nothing more than a speck of light, a tiny blip on a screen. Yet to the trained eyes of the Cassini imaging team, this faint speck held the promise of discovery. As the team analyzed the images, carefully tracking the object's movement, they realized that it was not following a random path. Instead, its trajectory indicated that it was gravitationally bound to Saturn, orbiting the ringed planet at a distance of roughly 22 million kilometers. The object's faintness suggested that it was relatively small, perhaps no more than a few kilometers in diameter. Despite its diminutive size, the discovery of this new moon sent ripples of excitement through the scientific community. The discovery of Fenrir was the culmination of the efforts of a dedicated team of astronomers and engineers who had poured years of their lives into the Cassini mission. While the official announcement of the discovery was made by a team led by planetary scientist David Jewett of the University of California, Los Angeles, the credit for finding Fenrir, like many other discoveries in astronomy, belongs to a larger group of individuals. The unsung heroes of this story are often the tireless individuals who spend countless hours poring over data, searching for the faintest hints of something new and unexpected. These individuals, driven by a thirst for knowledge and a passion for exploration, are the lifeblood of scientific discovery. Their dedication and perseverance are a testament to the power of human curiosity and our innate desire to understand the universe around us. The discovery of Fenrir, a testament to their hard work and dedication, added another piece to the puzzle of our solar system. The discovery of a new celestial object is always an exciting event, but it also presents a unique challenge: choosing a name. The International Astronomical Union selected the name Fenrir for Saturn's newly discovered moon. In Norse mythology, Fenrir is a monstrous wolf, a fitting namesake for a moon orbiting Saturn. Fenrir, like many of Saturn's outer moons, is a small and faint object, a testament to the challenges of observing these distant worlds. Its estimated diameter of just 4 kilometers places it among the smallest moons in the Saturnian system, a mere speck of rock and ice dwarfed by its colossal planetary companion. To put its size into perspective, Fenrir is about 1/6 the diameter of Phobos, the larger of Mars' 2 moons, and roughly 1/2000th the diameter of Earth. Despite its diminutive size, Fenrir's gravity is strong enough to hold onto its shape, giving it a nearly spherical form. This is in contrast to even smaller objects, which often lack the gravitational pull to overcome their own rigidity and tend to be irregularly shaped. Imagine a pebble compared to a basketball. Both are distinct objects, but their size dictates their form. Fenrir's near-spherical shape provides a clue to its internal structure, suggesting that it is likely a solid body rather than a loosely bound rubble pile. Section 2. A surface scarred by time. While no spacecraft has ever visited Fenrir up close, astronomers have been able to glean some information about its surface from observations made by telescopes both on Earth and in space. These observations, combined with our understanding of other icy moons in the outer solar system, paint a picture of a world shaped by billions of years of bombardment by meteoroids and micrometeoroids. Fenrir's surface is therefore likely heavily cratered, a testament to its long history of collisions with space debris. Imagine a pristine, freshly fallen snowfield. Over time, as snowflakes accumulate and melt, the surface becomes pockmarked and uneven. Similarly, Fenrir's surface bears the scars of countless impacts, each crater a record of a past collision. These craters, ranging in size from microscopic pits to larger depressions, tell a story of constant bombardment, a reminder of the dynamic and often violent nature of our solar system. Section 3. Composition clues to Fenrir's past. The composition of Fenrir, like that of many other outer solar system moons, is thought to be primarily a mixture of water ice and rock. This conclusion is based on its low density, which is typical of objects rich in ice, and its dark surface, which suggests the presence of rocky materials mixed with the ice. The exact proportions of ice and rock remain unknown, but scientists estimate that Fenrir's composition is similar to that of other irregular satellites of Saturn. Imagine a scoop of rocky road ice cream, with chunks of chocolate and nuts embedded in a creamy base. Similarly, Fenrir's interior likely consists of a mixture of water ice, acting as the creamy base, and rocky material, represented by the chunks scattered throughout. This blend of ice and rock provides clues to Fenrir's formation, suggesting that it coalesced from the same primordial disk of material that gave rise to Saturn and its other moons. Section 4. Unraveling the mysteries of Fenrir's surface. While the overall picture of Fenrir's surface is one of a heavily cratered, icy world, there may be more to this distant moon than meets the eye. For instance, variations in the reflectivity of its surface suggest that different regions may have different compositions or have been exposed to different degrees of space weathering. These subtle variations hint at a more complex history than a simple, uniformly cratered surface. Imagine a map of Earth with its diverse landscapes of mountains, deserts, and oceans. While we currently lack the resolution to see such details on Fenrir, the subtle variations in its surface reflectivity suggest that it too may possess a more diverse landscape than we currently understand. Unraveling the mysteries of Fenrir's surface will require closer observations, perhaps from a future mission dedicated to studying Saturn's outer moons. A distant dance around a ringed giant. Fenrir circles Saturn at a distance of roughly 22 million kilometers, placing it among the ringed planet's outer retinue of moons. This vast distance means that Fenrir takes its time to complete one orbit around Saturn, with a year on Fenrir lasting approximately 1,352 Earth days. This leisurely pace stands in stark contrast to the rapid orbits of Saturn's inner moons, some of which circle the planet in a matter of hours. Imagine a graceful waltz, with Saturn as the central figure and its moons as dancers swirling around it. Fenrir, in this cosmic ballet, would be a distant observer, slowly gliding along the periphery of the dance floor. Its orbit, far from being perfectly circular, is significantly elongated, resembling an ellipse rather than a circle. This means that Fenrir's distance from Saturn varies throughout its orbit, bringing it closer to the planet at some points and carrying it farther away at others. Navigating a sea of ice and dust. Fenrir's orbit lies beyond the main extent of Saturn's majestic rings, but it is not entirely free from their influence. The rings, composed primarily of ice particles ranging in size from tiny grains to house-sized boulders, cast a faint but persistent shadow on the moons that orbit within their plane. While Fenrir's inclined orbit means that it does not pass directly through the densest regions of the rings, it still encounters a tenuous rain of ring particles throughout its journey. Imagine a ship sailing through a dense fog bank. While the ship itself may not collide with any large objects, the constant presence of moisture and mist leaves its mark on the vessel. Similarly, Fenrir's surface is constantly bombarded by a subtle but steady stream of ring particles, each impact contributing to the slow erosion and weathering of its icy exterior. Gravitational choreography, Fenrir's influence. Despite its small size, Fenrir is not merely a passive player in the intricate gravitational ballet of the Saturnian system. Like all celestial objects, Fenrir exerts a gravitational pull on its surroundings, however minuscule it may be. This gravitational influence, while subtle, can have a measurable effect on the orbits of nearby objects, particularly other small moons and ring particles. Imagine a pebble dropped into a still pond. The pebble itself may be small, but its impact creates ripples that spread outward, disturbing the tranquility of the water's surface. Similarly, Fenrir's gravity creates subtle perturbations in the orbits of nearby objects, nudging them slightly off course and contributing to the complex dynamics of the Saturnian system. Section 4. A Journey Through Time. Fenrir's Orbital Evolution. Fenrir's orbit, like those of many other irregular satellites, is not static but rather evolves over time due to the complex interplay of gravitational forces in the Saturnian system. These forces, acting over millions of years, can cause subtle changes in Fenrir's orbital path, gradually altering its distance from Saturn, the shape of its orbit, and even its orbital inclination. Imagine a spinning top beginning to wobble as it loses momentum. Just as the top's axis of rotation slowly shifts, Fenrir's orbit undergoes gradual changes over vast stretches of time. Studying these orbital variations provides valuable insights into the long-term evolution of the Saturnian system and helps us understand how the intricate dance of Saturn's moons came to be. Section 1. Whispers from the Depths. Potential for activity. Given its small size and distant location, Fenrir might appear to be a cold, geologically inert world. However, appearances can be deceiving in the realm of celestial bodies. Scientists have learned from studying other icy moons, such as Jupiter's Europa and Saturn's own Enceladus, that even small icy worlds can harbor surprising levels of internal activity. These moons, despite their frigid surfaces, possess internal oceans of liquid water, kept warm by the gravitational tug-of-war with their giant host planets and neighboring moons. Could Fenrir, like its more famous counterparts, harbor a hidden ocean beneath its icy shell? While we don't have any direct evidence to support this possibility yet, it remains an intriguing question for future exploration. The presence of geological activity, such as ice volcanoes or geysers, would suggest internal heating and increase the likelihood of a subsurface ocean. Such an ocean, if present, would be of immense interest to scientists searching for life beyond Earth, as it could potentially provide the necessary conditions for life as we know it to exist. Section 2. A surface of secrets, what lies beneath. Our current understanding of Fenrir's surface is limited by the resolution of our telescopes and the fact that no spacecraft has ever visited this distant world up close. However, even from afar, we can discern subtle variations in its surface reflectivity, hinting at a more complex and diverse landscape than a simple, uniformly cratered terrain. These variations could be due to differences in the composition of surface materials, the presence of impact craters of varying ages, or even the remnants of past geological activity. Imagine an archaeologist carefully brushing away layers of sediment to reveal the ruins of an ancient city. Similarly, scientists studying Fenrir hope to one day penetrate its veil of ice and dust to uncover the secrets hidden beneath its surface. A future mission equipped with more sensitive instruments could map Fenrir's surface in greater detail, revealing the presence of impact basins, ancient fault lines, or even signs of cryovolcanic activity. One intriguing aspect of Fenrir is its coloration, which appears distinctly different from that of many other Saturnian moons. While most of Saturn's icy moons exhibit a relatively bright reflective surface, Fenrir appears noticeably darker, with a reddish hue. This suggests that Fenrir's surface may be richer in organic molecules, complex carbon-based compounds that are found throughout the solar system and are considered to be the building blocks of life. Imagine a painter's palette, with Fenrir's reddish hue standing out among the more muted tones of its neighboring moons. This difference in color tells us something about the composition of Fenrir's surface and hints at the possibility that it has been exposed to different processes than its brighter counterparts. The presence of organic molecules on Fenrir's surface would be of great interest to astrobiologists, as these compounds are considered to be essential ingredients for life as we know it. Fenrir, along with Saturn's other irregular satellites, is believed to be a captured object, originating from the outer reaches of the early solar system. These objects, remnants of the primordial disk of gas and dust that gave rise to our solar system, hold valuable clues to the conditions that prevailed during this early epoch. By studying Fenrir's composition, orbit, and surface features, scientists hope to glean insights into the formation and evolution of the outer solar system. Imagine a time capsule, buried deep beneath layers of ice and rock, containing within it a snapshot of the early solar system. Fenrir, in many ways, represents such a time capsule, preserving within its icy embrace a record of the conditions that existed billions of years ago. By unraveling its secrets, we gain a deeper understanding not only of Fenrir itself, but also of the grand story of our solar system's birth and evolution. Fenrir, the wolf moon of Saturn, stands as a testament to the boundless capacity for discovery within our solar system. From a faint speck in Cassini's cameras to a world of scientific inquiry, Fenrir expands our understanding of planetary systems. Though small and distant, Fenrir plays a crucial role in our cosmic neighborhood. Its existence challenges our assumptions about moon formation and evolution. Fenrir's cratered surface speaks to a long and tumultuous history. Its reddish hue hints at a surface rich in organic molecules. The possibility of a subsurface ocean fuels our fascination with Fenrir. While our current knowledge of Fenrir is limited by distance and technology, the future holds the promise of exploration and discovery. Imagine a spacecraft with advanced sensors, mapping Fenrir's surface, revealing impact basins, fault lines, or cryovolcanic activity. Analyzing its ice composition, we trace its origins to the early solar system. Perhaps we might find a subsurface ocean, bringing us closer to answering if we are alone in the universe. Fenrir beckons us to explore beyond the familiar, embracing the unknown with wonder.